Hi everyone, in this video we're going to be looking at finding the determinant of a 2x2 matrix. Before we get into finding the determinant of a 2x2 matrix, let's just recap what is a 2x2 matrix. A 2x2 matrix, like this matrix we have here, matrix A, B, C, D, is a matrix where you have 2 rows and 2 columns, right? Cool. So to find the determinant of any matrix, the general form is we write DET, you can write DET A in this case because it's matrix A. So DET A for shorthand to find the determinant, or we put 2 lines and then the letter in between, right? So to find the determinant of any matrix, a 2x2 matrix, you find the product of the first diagonal. So this first diagonal here, you find the product, meaning you multiply the two letters or the 2 numbers when they have numbers. So we get A times D, and then we take away the product of the second diagonal, which would be B by C. So the determinant of any matrix, any 2x2 matrix, is the product of the first diagonal minus the product of the second diagonal. Now, let's look at some examples to be a little bit clearer when we do these examples here, right? So find the determinant of the following matrices is worked out here, but I'm going to go through it with you all. Well, the first 2 are worked out, right? So matrix M, right, to find the product of the first diagonal. So 5 times 2, take away the product of the second diagonal. So 5 times 2, take away 4 times 1. So then we get 10 minus 4, and that's equal to 6. So DETM is equal to 6. Determinant of M is equal to 6. Likewise, in number 2, matrix N is 4, 7, 6, 3. So the determinant is the product of the first diagonal. So 4 by 3, take away product of the second diagonal. So take away 7 times 6. So 4 by 3, take away 7 times 6. So that's 12, take away 42, and that's minus 13. Now let's look at our third example here that's not worked out. So let's see if we could go through this part here. Well, numbers 3 and 4 we're going to go to together. So the determinant, so DET, determinant of matrix D. So the product of the first diagonal, so that's minus 2 times 6. Take away the product of the second diagonal, so that's 5 times 3, right? So then we will get the determinant of matrix D, minus 12 minus 15, and we would get minus 27. That's my determinant. And now let's look at number 4. So the determinant of matrix L, same thing. So the product of the first diagonal, minus 1 times minus 3. Take away the product of the second diagonal, which is minus 5 times minus 2. So let's work out. Minus 1 times minus 3 is positive 3. Then take away minus 5 times minus 2 is positive 10. So it just becomes 3 take away 10, which is minus 7. Right? So it's pretty simple. Product of the first diagonal, take away the product of the second diagonal. So let's try this exercise. As always, you can pause the video, try the questions, and then come back to it, right? So, we want to find the determinant of number 1, determinant of matrix C. So the product of the first diagonal, right? So 9 times 3, take away the product of the second diagonal. So that's 4 times 2. So that's 18, take away, sorry, not 18, my bad. I meant to say 27, take away 8, right? 9 times 3 is 27, take away 4 by 2, which is 8. And when we subtract, we'll get 19. Number 2, determinant of matrix S. So first diagonal, 7 times 1. Take away the product of the second diagonal, 8 times 3. So that would be 7, take away 24. Now I know some of you all still trying to get the hang of the working out the directed numbers when you have negative numbers and so on, right? So you could use a calculator to double check at this point. So 7 take away 24, and we are going to get 17 minus 17, because small number take away a bigger number, right? And now let's look at number 3, determinant of P. So that's first diagonal minus 5 times 2. Take away minus 3 times minus 2. Right? That's second diagonal. Minus 5 times 2 is minus 10 minus 3 by minus 2. That's positive 6. So our answer be minus 16. And then last one, determinant of J. 1 times 7, take away 0 times 9. So the product of the first diagonal, take away product of the second diagonal, and we get 7 minus 0 by 9 is 0. That answer is 7. Right? So it's not hard. It's just different things to remember in matrices, different methods, but to work out the actual questions is not difficult. Now we're looking at singular matrices. Now, the reason why I'm doing singular matrices in this video as well is because it ties closely with the determinant of a matrix. So reading here, a matrix is singular if and only if its determinant is equal to 0. So if you work out the determinant of a matrix and it's 0, therefore it's a singular matrix. So looking at this example here, matrix A is 3, 12, 2, 8. So to find the determinant of A, we're going to determine whether it's singular or not, right? So determinant of A will be 3 by 8. Take away the next diagonal, which is 12 by 2. So 3 by 8 is 24. Take away 12 by 2 is 24 again. 24 take away 24 is 0. Therefore, this matrix is singular because the determinant is 0. Let's look at the other two examples. Number 2 here. So determinant of B, again, first diagonal, minus 2 by 4. Take away the product of the second diagonal, minus 8 by 1. So minus 2 by 4 is minus 8. Then take away minus 8 by 1 is also minus 8. So with two minuses together, remember, gives you a plus. So minus 8 plus 8 gives me 0. Therefore, matrix B is, the determinant of matrix B is 0. Therefore, it's a singular matrix. Let's look at number 3. Matrix C is 1, 6, 2, 5. Determinant of C is 1 by 5. Product of the first diagonal, take away 6 by 2. And we will get 5, take away 12, which is minus 7. The determinant of matrix C is not 0. Therefore, the matrix is not singular. So, a matrix is singular only if the determinant is equal to 0. Right? So let's look at some other questions. So let's look at this interesting question. It says given a matrix P is singular, find the value of x. So this is matrix P here. Matrix P is x, 6, 7, 3. They are telling us that that matrix P is singular. So matrix P is singular, therefore the determinant of P, matrix P, has to be 0. We want to find the value of x. How do we find the determinant again? First diagonal, product of the first diagonal. So x times 3, take away the product of the second diagonal, which is 6 times 7. And that's equal to 0, because it told us the determinant is, the matrix is singular, so the determinant is 0. So x by 3 is 3x minus 42 equals 0. So carry across the take away 42 becomes plus 42. So 3x is equal to 42. And remember, 3x is the same as 3 times x. 3 times x equals 42. So therefore, x is equal to 42 divided by 3. Right? And when we divide that, we will get, let's work it out here so you could see. 3 into 3, 1. 3 into 4 is 1 remainder. My bad. We're a little bit haywire there. Right. 3 into 3, 1. 3 into 4, 1. Remainder 1. Right, it's not coming up there. 1, remainder 1. So we get 14. Sorry, I don't know why I keep on erasing, right? But 42 divided by 3 is 14. So x is 14. Right? Alright, so last of the questions. Find the determinant of the following matrices and state which one of them are singular. Right, so let's just move around this one here to get some space. Alright, so let's do number 1 first. So determinant of matrix G, 4 by 4, take away 8 or 2 by 8 or 8 by 2, doesn't matter which one it is. So 4 by 4 is 16, take away 16. The determinant is 0, so determinant of G is 0. So therefore, matrix G is, right? Let's get number 2. So determinant of H, 3 by 5, take away 4 by minus 7. So the product of the first diagonal minus the product of the second diagonal. So we will get 15, take away 4 by minus 7 is minus 28. So remember, when you have two minuses, it becomes plus. So 15 plus 28, right? And then we will get 43. So therefore, this is not singular because the determinant is not 0, right? So just keep that in mind, right? A matrix, just before we move on, matrix is singular only when the determinant is equal to 0. If it's not equal to 0, then it's not singular. Alright, so let's look at the next two we have here. And we have a question below there. Alright, so the determinant of K would be 9 by 4 take away 3 by 12. So that's 36, take away 36, which is 0. So therefore, matrix K is singular. Right? And now number 4, determinant of L. First diagonal product, 4 by 3, take away product of the second diagonal, minus 2 by minus 6 is positive 12, which is just 12. And this is also 0, therefore this is singular as well. So matrix L is also singular. Right? And now, let's look at this last question here. So given that matrix W is singular, find the value of X. Matrix W is X5, 4, 2, and we are given the information the determinant of the matrix is 0. So to find the determinant, well, how we'll work it out? So X by 2 minus 5 by 4. And that is equal to 0. X by 2 minus 20 is equal to 0. So X by 2, I'm leaving it as X by 2. You can put it as 2X. I'll just leave it at one time, right? Is equal to 0. Opposite of taking away 20 is adding 20. So X by itself, carry across the multiplication by 2. It becomes 20 divided by 2, which is 10. The value of X is 10, right? So very simple. Take your time. Just go over the questions and you will get it. It's all about practice, as I always say, sorry. So I will see you all in my next video.